All right, so now that we know how to identify parallel resistors or components, let's take a look at a few examples on how to add parallel resistors. All right, so this circle right here shows two resistors in parallel. This is probably the simplest form of a parallel network or circuit that you're gonna see. Just two resistors in parallel, and so there's actually two ways you can do it. I'll show you one way, which is if we want to add them up. So we call this R total. Okay, we're adding these two resistors up. We're trying to find the equivalence of these two resistors. So we call that R total equals, and the one way you can do it, you can do the product over the sum, which is R1 times R2 divided by R1 plus R2. And so, of course, you just plug in your numbers, so that'd be 1 kilo ohm times 3.5 kilo ohm divided by 1 kilo ohm plus 3.5 kilo ohms. And so if we plug this into our calculator, so we have 1 e to the 3 times 3.5 e to the 3 divided by 1 e to the 3 plus 3.5 e to the 3. You get 777.78 ohms. All right, so that's one way you can do it. The next way you can do it is you can use the 1/over method. Or at least that's what I call it. I call it a 1/over method. So, and this formula looks like this. So you say 1 over 1 over R1 plus 1 over R2. And so we plug our values in. You have 1 over R1, which is 1 kilo ohm, plus 1 over R2, which is 3.5 kilo ohms. And now we plug this into our equation, our calculator. This is how you write it in. So 1 over, you got to do another 1 over to the 3 plus 1 over 3.5 e to the 3. You get the same thing. So my thoughts on both of them. I mean, this one right here works for quick, simple circuits like this. However, I like this one as well. This one may look a little intimidating at first because of the whole 1/over thing. But the advantage that this one has over this one is that this can work for a number of resistors, as will learn later in the next example, actually, that what if you had 3 resistors? Well, this one won't work right away. You have to do 2 at a time. But this one, you can go ahead and plug all your resistors into this form right here. 1 over R3, 1 over R4, and beyond. So This one right here is limitless on the number of resistors that um you can have or that you can plug into that formula. Well, let's take a look at this one right here. So if we do it the first way, like I said, you can only use that first equation with the product over the sum with only two resistors. But in this case, we have three. So you have to pick two resistors to add first, combine those two, and then you apply the same formula to the next resistor. And I'll show you what I'm talking about. So let's just add R1 and R2 together in parallel. And so we'll say let's see, R1 parallel with R2. And so you do the product of a sum, 1 kilo ohm times 3.5 kilo ohms divided by 1 kilo ohm plus 3.5 kilo ohms. And this is basically what we had before, which was 777.78. 777.78 ohms. Now we have to, so now what we have just done is we combine these two together and made one equivalent resistor, which is 777.78 ohms. So now we can take this value right here and apply the same formula to the next resistor to get the R total. And then your R total would equal, we'll call it R1 parallel R2 times R3 over R1 parallel R2 plus R3. And so just plug and chug, 777.78 ohms times 2 kilo ohms over 777.78 ohms plus 2 kilo ohms. All right, so we plug that into our calculator. All right, so we get 777.78 times 2 each of 3 divided by 777.78 plus 2 each of 3. And you get 560 ohms. Now, if we did it the other way, you can just do it straight up. We can go ahead and already do it. So we can say R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And just plug and chug. 1 over R1, which is 1 kilo ohm, plus 1 over R2, which is 3.5 kilo ohms, plus 1 over R3, which is 2 kilo ohms. And when we plug it into the calculator, we get 1 over 1 kilo ohm plus 1 over 3.5 kiloohms plus 1 over 2 kiloohms. Get the same thing as expected. 560 ohms is what we get. So when you're looking at two methods, I mean, they have their advantages. I tend to gravitate towards this one because it's one, you only have to memorize one equation and how to apply it. Yeah, I still use this one from time to time on just some simple circuits that have just only two resistors. Um, but if I was you, I would get in the habit of using this one. It's going to save you a lot of times and a lot of error. You're going to have to practice with it a little bit more because it's kind of weird the way you have to put into the calculator because the 1 over R1, R2, R3 thing you have to put in there. But I think it'll be more beneficial if you would get used to using this one. But to each his own. I mean, you're welcome to use whatever method that you feel you're more comfortable with using. But I just wanted to show you both ways. So that's it for this topic. And on the next video, we'll talk about how to analyze a parallel network or a parallel circuit. Thank you.